Hello everyone. Okay, hope you all can hear me. So we were planning about creating a PySpark job, and we couldn't able to create. We were facing a problem with the data pro cluster, right? So let us try to do it today. So if you remember, guys, so this is our plan. So assume that we have a cloud storage bucket. Assume that we have a cloud storage bucket, and inside that we have a two CSV files. One is students students.csv. One more is grades.csv. Assume that you have a two CSV files. One is students.csv as well as grades.csv that is there in the GCS bucket. Okay. So we have to move this data to the BigQuery. So we need to create a table in the BigQuery and we need to load this data to the BigQuery table. Okay. So we need to load that as a table in the BigQuery. So this is our agenda, sir. For doing that, we are going to do a lot of transformations. We need to join these two CSV files. We need to first create a data frame, join them, aggregate them, and then we will try to load this data to a BigQuery table. And this is what is our agenda. Okay. So this is our agenda, guys. Any question here? Fine. Okay. So first we will try to create it as a data frame. So this is data frame 1, this is data frame 2, and then we will try to join them, and then we will try to apply some other transformations, one or two transformations, and then we will try to load this data to the table. So let us try to do this activity so that you guys get to know how we can create a job in the PySpark. So all of these things we are going to do it in the PySpark only in the data prop. Okay, so let us plan doing that. So we see here the cluster is created. I'm going to click on the cluster. Click on the web interfaces. Click on the Jupyter Lab.
A cluster is already created, sir.
Just now, yes. So you guys can see here the cluster is just now created. Okay, I'm going to click on this PySpark notebook. Okay, so let me increase the size. Okay, so let me open the cloud storage as well. Let us see whether we have those files available or not. Let me go to the cloud storage. So let me click on the bucket. You guys can see here we have a students.csv and maybe let me go here. And yeah, you guys can see here, right? So we have a grades.csv and students.csv. So let us try to create these as the data frames in the data prop cluster first. So first let me go here. So I would say source connection. Okay. So let us try to create it as a data frames. The very first thing is that first we have students path. Similarly, we have grades path. So these are the input paths I'm creating, guys. So the input path for the CSV file that is available in the Google Cloud Storage, I'm going to click on the CSV file, copy this path and paste it here. Similarly, for the grades path, go to that particular file, click on the file, copy this particular path and paste it here. So this is how it is, guys. Next, we need to create a data frame. So data frame 1 is equal to spark.read.csv. So if we are having a CSV file, we are going to read the data from the spark.read.csv and mention the student's path. Copy the path and paste it here. Similarly, df2, okay, let us say df1 dot show. And if you wanted to say df1 dot print schema. So if you wanted to print the schema also, you can do that. Okay. So now let me run this one so that let us just see whether we are able to read the data from the Google Cloud Storage bucket or not. So if we are able to read it, we are able to see the data also, and we can also able to print the schema as well. So let me click on this play button so that it is going to be running. You guys can see here, it started running now. See, we are able to successfully read the data. Can anyone tell me what is the problem with this particular data reading? So we are reading the data. Are we reading the data properly? And is there anything fishy about this particular data, guys?
Better information. Also,
Correct. So we have not read the data properly. So you guys can see here the header we have to mention properly. So that means here we will go here and we will try to mention header is equal to true, so that while it is reading the data, if the CSV file is already having the column names or a header, then we will mention here a header is equal to true, so that you can able to see it here now. See here, now the header came at the top and you have the records here. And if you wanted to show only first 5 records, you can able to just limit it to the 5 records also. That is totally fine. Okay, this is how we are able to read the data from the student CSV file, and we are able to see the data also. So this is how it is. Similarly, I wanted to do it the same thing for the df2. Okay, df2 and df2.show df2, and it is grades path. I will mention it is a grades path. You guys can see here, I am running the entire cell so that we will be able to see two things. One is students, sorry. Both it read as, yeah, you guys can see here. Sorry. So here we have the students data frame. Here we have a grades data frame. So this is how first we are able to read the data. The very first thing is that we need to, whatever the file it is, whether it is a CSV file, JSON file, agro file, Parquet file, we must be able to read the data from that particular file, and we should be able to properly read it and see the data. Once we are able to create a data frame, we need to apply the transformation on top of this data frame. Okay, so that is how we have to do it, guys. For first we are able to read the data. This is what we have done it. Now once the data frame is created, let us try to do few transformations. So the very first thing I will try to do is that if the data frames are having any duplicates, assume that if I wanted to drop any kind of a duplicate that is there in the data frame, I am going to drop it. Drop duplicates or remove the duplicates. Remove the duplicates. This is what happens, right? So when you are dealing with the data, there can be a duplicate. So that is the reason we will try to drop the duplicates. So df1 is equals to df1 dot drop duplicates. I am going to use drop duplicates function. Similarly, df2 is equal to df2 dot drop duplicates. I am dropping the duplicates so that even though in the future also if the duplicates are comes, so it will be dropped properly. Okay, so that is how it is. So we are able to dropping the duplicates with the help of the drop duplicates function. Okay, so that is how it is, guys. Does anyone have any questions so far?
Header true, what it will do, sir, that one?
I've shown you, right? If you don't mention the header true, what will happen also I have shown you. Right, what is happening?
Okay, header names are not coming.
Okay. So if you don't mention the header, it does not, it consider that the entire CSV file is a data. Okay, so it will be creating it as a data and it creates a new columns. Okay, so if you mention header is equal to true, that means it will understand that in your CSV file you have the column names and it will consider the first row as a column names. So that is what it will do. Okay, so now we have removed the duplicates also. Now let us try to join the two data frames, guys. Now let us see df1 dot show 1. So let us see 3 records each or 5 records each. So I have here df1 dot show. Similarly, df2 dot show also. So we have here df1 dot show, df2 dot show. So if you wanted to see the count also, you can able to see it here, guys. For example, I want to see the count of these things. Okay, you can able to see the count also. Okay. So it is count 88, it is count 40. In the data frame 1, you have the count 40, sir. And in the data frame 2, you have the count 88. So in the data frame 2, you have total number of records are 88. In the data frame 1, you have total number of records is equal to 40. So that is how it is. So now look at here, guys. So I wanted to show you the data because we are going to join these two tables. Look at here, sir. I wanted to, the client don't wanted to see them as in two different tables. He wanted to see it as in one table only. We are going to join these two tables. So here we have a student's ID, here we have a grades details. So how do we join it, guys? Can you guys tell me what is the joining condition here? How we can do it, how we can do the joining?
Based on the student ID.
Correct. Based on the student ID, we can able to join these two tables, right? So let me gonna do that. So join operation.
But if you see, okay, so these are the top 5 rows only. Got it.
Okay. So guys, look at here. We have a student ID. So let me gonna say df1 is equal to df1 dot, sorry, df1 join. I would say is equal to df1 dot join df2. I am joining the df1 with the df2 on the condition we have to mention here. Okay, so this is how the syntax is, guys. So df1 join it with the df2 and the condition we have to mention, the condition is that df1 students id is equals to df2 dot students id. Okay, so this is how you have to mention the joining condition. So the joining condition is that df1 dot students id is equal to df2 dot students id, and you have to mention the join type. Whether it is inner, you mention the inner. If it is the outer, you mention the outer. If it is left join, right join, whatever it is, you try to mention everything here. Okay, so this is how I am going to mention the joining conditions. So look at here. So if you wanted to join any of the tables, you can able to do it like this. We have a df join, df1 joining with the df2. So we have a data frame 1 and data frame 2. Data frame 1 is joined with the data frame 2 on an inner join. The condition is that on student ID. Okay, so now if you wanted to see the data, df underscore join dot show. If you wanted to see the entire data, you can able to see truncate is equal to false. If you mention truncate is equal to false, all the records it is going to be showing. Student ID. Okay, the column name is student ID, guys. It is not student's ID. Student ID. Okay, run it. See here, truncate is equal to false means all the okay. Okay, let me say truncate is equal to false means okay, 50. Let me share all the 50 records I wanted to show. So it is showing all the records, guys. Okay, so if you wanted to show all 100 records, 1000 records also, it will show. Only it is having only some 88 records, I believe. So all 88 records it is going to be showing. Look at here. So this is how it is. So student ID, name, age, gender. Again, student ID is came, subject came, grade came. Now, sir, here we have the student ID. Here also we have the student ID. We need to drop the one of the student ID. Can you guys tell me what we have to do? Can anyone tell me what we can do?
Need to list the columns.
So there are two things that we can do. We can select the columns, the required columns, or we can also drop this column. Okay, student ID drop, we can also drop it. So while we are doing the joining operation, if you wanted to drop the student ID, you can also drop it, drop. So which student ID we don't want? The df2 student ID I don't want. You can drop it. So this is also you can do. Okay. So now look at here. So I have dropped the student ID. Second student ID, I have dropped it. So this is how you will be able to drop it also. Whenever you wanted to drop a column, you can also drop it. Okay. So this is how it is, guys. Any questions, anyone so far?
So will it support all the ANSI joins like left join or right join?
Correct. So here you can mention left join, right join, inner join, left anti, right anti, all the joins it is going to be supporting. Okay. Yeah. So this is how you'll be able to drop it also, guys. So we have dropped that particular column also. Now you have student ID, name, age, gender, subject, and grade. So this is how you have got the entire table. So now the client don't wanted to see the entire data. He is more interested in those people whose marks are more than 85%. And he wanted to add, he wanted to add one more column, that is pass percentage column. Okay, add a percentage column, pass percentage column we need to add, guys. Okay, so can anyone tell me how do we do that? For example, we have here df underscore join is there. So this is what is our df underscore join dot show. So I wanted to show only 5 records or 4 records. Let me gonna show you. So here we have this one, sir. Sir, I wanted to add a percentage. So what is mean by percentage, sir? So how do we get the percentage?
So grade divided, I mean,
Yes.
so grade divided by total marks into 100.
Correct. So get divided by total marks. So for example, let me take only one person. Okay. So I would like to see one person. Filter. I wanted to add a filter so that I can able to see one of the person, that is students ID. is equal to 1. Okay. So cannot be a string. So let me just say like this.
No, the student name is incorrect.
It is student ID only, right? So let
No,
me
no,
say,
student name is incorrect. That is ST. Okay,
okay.
correct only.
Okay, so let me do that. So usually we can mention df dot student ID. Kernel is connecting.
Maybe student ID one is not there. So
Oh, it's not there. No, it will show, right? Even though it is not there, it will show. Okay. So something wrong with the clusters only.
I think it is confused from which data frame to take.
Let us mention df underscore join dot student ID. Okay. Now let's run it. Okay. Yeah, we have restarted the cluster, right? So let me run all the cells. So it is going to be running all the cells one by one more time. So let us wait. So we are able to read, we are able to read, we are able to read. So here it is. So for the student ID, we do not have any records. Maybe let us take 5. So it is how this is how it is, guys. So we have only two actually. We have only two subject. One is this one, that is physics and maths. Okay. So I wanted to add a one more column, that is percentage of the particular, so let us take it as percentage. Let us try to add. So percentage is that, so total okay, so this is how the marks by the total marks, right? The marks in that particular subject by the total marks, that is we wanted to find it out. Okay, so if I wanted to find the percentage, so what I will do, so total marks is 200 because two subjects only we have, and for each subject it is 85. So that's the reason the percentage is equal to 85 by 200. Okay, if I mention 85 by, okay, let us mention as 85 by 100. Okay, so I wanted to add one more column, that is, for example, let us try to see df underscore join. Okay, df underscore percentage, let me say percentage is equal to df underscore join. Okay, dot, we wanted to add a column, so whenever we wanted to add a column, we can say with the column we can add it, we will say percentage. Okay, percentage is equals to, so for each marks we are just dividing it by 100 marks, so that they'll get the pass percentage for each subject, for each subject. Okay, so for each subject we wanted to find the percentage. So for each subject we will take it as a grade column, so that is df underscore join underscore grade. So this is my grade column. So divided by, I wanted to do 100, divided by, I wanted to do 100, so that we will be able to get the percentage. Okay, so usually, so this is not a proper column. So let me just think about it, if we can add any other column. Yeah, let us try to add one more column, guys, which is a country of these people. Okay, let us not worry about that. Sir, I wanted to add a country of that particular column. So for all of these students, we wanted to add a city or country. So for all these people are coming from the India. So let us try to add them as a country as an India. Okay, so let us try to add. So the main intention is that I wanted to just add a one more column, which is whether it is a country column or whether it is a city column or whatever it is. Just wanted to add one more column so that you guys get to know how we can add a column in the data frame. So if I wanted to add a column, so you guys can see here, sir, country column, and I wanted to add a value as India. Okay, so it is a function to provide the country column. So we have to from import them. We have to from PySpark.sql.functions import lit. So we are going to add a lit function. We are going to use the lit function for the constant value for all the students. The country name should be India only. So it is a constant value throughout all the column. So that's the reason we are going to use the lit function. So you guys can see here now. So it ran successfully. If I wanted to see it, okay, dot show, I would say maybe let us take it as 7 records. Let us try to see. So you guys can see here. So we have added a one more column, that is a country column. For all the two students, we have added a country as a India only. So this is how, if you wanted to add it, you can able to add it easily. Okay, so this is how, sir, we have doing a few transformations such as, so as per the requirement, as per your business requirement, we are going to add each and every transformation, guys. So first we read the data and we transform the data using we drop the duplicates, we do the joining operation, and we do this one also. And sir, if you wanted to do any of the transformations also, we can also do it. Okay, any question here, sir, so far?
Can you please copy this into Notepad, sir? That will be helpful for us.
So it's a notepad only, I can download it. Okay, so that is how you can able to drop it, sir. Now the thing is that we don't want it to see all the data. So the requirement is that we need to first we need to calculate the average grade for each student. So that is the requirement. The requirement is that average grade we wanted to find, and the client is more interested in towards those people whose average grade is more than 80, whose average grade is more than 80. So for that one, we need to first, what, sir, we need to do, we need to add a column for the average grade. Then we need to filter the data for the average grade. So for that, so now I am going to do, so I am going to try to add one more column. So that is df underscore average grade. So for this one, what I'm trying to do, so df underscore percentage dot. So whenever you wanted to find the average grade, what we have to do, sir? Can anyone tell me? So I wanted to find the average grade, sir. In the SQL, what do you try to do? So you will be doing the group by, right? So you first group the data based on the student ID, and you can average. You can do the average based on the grade column, so that you will be able to get the average grade, right? So now student ID I am going to insert here. Okay. So and aggregate function I am going to use. That aggregate function is average, and I'm going to call the column name is df underscore percentage dot grade. So this is a column name. Okay, if you wanted to alias this column also, you can do that. Dot alias as average grade. So this is how it is, guys. Now these aggregate functions are not directly available. We need to import that. Okay, we need to import that. So that is from PySpark.sql.functions import average. Okay, so now I have mentioned here So aggregate functions, I am trying to do the group by based on the student ID and aggregating the data based on this particular column and aliasing this particular column as this one. Okay, so this is how you can able to do it, sir. Once you have done it properly, so if you wanted to see the data also, you can able to do it, dot show. So let us try to perform it, and if you see if issues are there in the code. So that is how you see here, guys. So we have the student ID and we have this average grade also. Okay, we have the student ID and we have also the average grade also is there. So this is how you'll be able to do it, guys. Okay, so once you have got it, sir, now we are not interested towards those people whose average grade is less than 85%. We wanted to see those people whose grade is more than 85 only. So for that, so let me mention here 5 only. So this is how we got the student ID. We have the average grade. So what I'm trying to do is that, so we wanted to filter the data. Filter out average grade. Average grade should be more than 85% only. So for that one, so I'm going to do df underscore filter. We wanted to apply the filter condition. So filter condition on this particular data frame, copy the data frame, dot, apply the filter, and you will be able to see, sir, if I wanted to apply the filter based on this grade, right? So that is average grade. So that is df underscore average. The column name is dot average grade. So this is my average grade, should be more than 85 or less, more than I mean to say greater than or equal to 85. So this is how you can able to see if you wanted to see df underscore filter dot show. Okay, so you'll be able to see it now. So this is how it is, guys. So you'll be able to see all of those people whose average grade is more than 85 only. Okay, so earlier if you wanted to see the count here for this one, dot count, if you wanted to see, so the count is so it is not showing the count. Okay, here it is, the 40. It has 40 records. Now if you are seeing the count here, df filter, you will be able to see the less count. It is because some of those people whose average grade is now less than 85, right? So that is the reason. So you can see here, guys, it is only 31. That means 9 people are there. That means 9 students are there whose average grade is less than 85. So that is the reason they are not included. Okay, so this is how whenever you wanted to transform your data, first you try to read the data. You transform the data as per your requirement, removing the duplicates. So remove this particular thing if you don't want it to see it, and joining operation, and if you wanted to find the percentage, if you wanted to add a constant column, sir, I have added a constant column here. And if you wanted to find the average grade and filter out the average grade, so this is how we have done all of those things, guys. Now I wanted to load this data to BigQuery. So if you wanted to load this data to the BigQuery, we need to find how to write to load this data to the BigQuery, guys. Okay, so now so far we have read the data from this particular Google Cloud Storage, and now we are writing it to the BigQuery, right? So let me open the BigQuery also. So let me go to the BigQuery. Okay, so let me go to the BigQuery and open the data set. So here we have the bronze data set. Okay, so let me, no, this is having a lot of tables. So let me create one more data set. Okay, let me say inside data set, create this as a data set. So I wanted to load the data to this particular data set, guys. I wanted to load that particular table to this particular inside data set. So how do we do that? Let us try to see. Okay, so whenever you wanted to write the data, what is the data frame you wanted to write? So my data frame is df filter. Okay, you can see here df filter dot write dot format. You can mention the format is equal to BigQuery. So this is how you have to mention, guys. So whenever you wanted to write the data to the BigQuery, so this is how you have to mention. Close the brackets here. But inside the bracket, we have to mention from to where we have to write it. So to where we have to write it. Sir, I wanted to write it to the option called table. We have to mention the table. So we have to mention the table. So if you wanted to write it to the particular thing, so here I have it actually. So you can able to see here, right? So whenever you wanted to write it to the BigQuery, so df dot write. So I'm gonna just tell you guys, look at here. So you have to write df dot write. The format is equal to BigQuery. The option, we have to mention the table name, and temporary GCS bucket we have to mention, and the mode, whether it is append or overwrite, let us try to mention. So let me look at here. So option, comma, we have to mention the table ID here. So what is the table ID? I will try to add. So the table ID is that which table you wanted to write it to. Sir, I wanted to write it to this particular data set. Okay, I wanted to write it to this particular data set. Copy this one. Dot, we can say it is a students table. So this is how you have to mention the students table. So the table ID, that means that whatever the data that is there in the DF filter, it will go to that particular table only. So now we are mentioning option we have mentioned. One more option is that we have to mention temporary GCS bucket, guys. Temporary GCS bucket. So we have to mention some bucket as a temporary GCS bucket. You can take any bucket as a temporary GCS bucket. I'm copying this one. Okay. So this is temporary GCS bucket we are mentioning. And finally, we are going to mention the mode. So the mode is whether you wanted to go for append or override or whatever it is. Finally, dot save. Okay. So this is how df dot filter as write, format BigQuery, option table. So to where we wanted to write it, you have to mention the table ID. So I have mentioned that table ID as a variable here and use that variable here. The option is temporary GCS bucket I have mentioned here. The mode, append, the save. So this is how whenever you wanted to load the data to the BigQuery, this format of the syntax you can use it. So when you wanted to run it, shift plus enter, if you do it, it is going to be writing the data to the BigQuery. So now you do not have any tables under this data set, right? So whenever you are writing something wrong here, let us see. Okay. So you don't need to mention this GS colon slash slash. Now run it. So it is running, you guys can see here. It is started running. It is almost completed. So this star, if it becomes a number, right? That means the processing of that particular cell is completed. So it is done now. You can go to that particular data set, click on three dots and refresh this content. You'll be able to see here students table is created. So this is how you have the student ID and average grade. So you have total 31 records are there. If you wanted to preview the data also, you'll be able to do it. So this is how, if you wanted to perform any kind of a transformations, guys, using the PySpark, this is how you have to do it. So this is one of the job where you read the data from the GCS and you have loaded the data to the BigQuery. And by doing all of these transformations. Okay, so this is how you have to create the end-to-end jobs, guys. Okay, so the requirement now, it could be a little simple, but when you are going for the company, the requirements going to be a little complex, but the process is the same thing. So as per the requirement, you have to do the aggregation, joining, or substrings, or if you wanted to find any kind of string operations, ranking functions, anything, if you wanted to do it, you can able to do it here, guys. Okay, filtering the data, grouping the data, all of those transformations will be able to apply like this. Okay, so this is how it looks like, guys. Any question?
Question.
Yes,
So
please.
the methods we are using here, spark.read and show print
1
schema.
minute. 1 minute, please. 1 minute. Yes, please, guys. Yeah, someone is asking a question. Yes, please.
Yeah, so these methods which we are using, right? Spark.read, show, print schema.
Correct.
So
Correct.
all methods are given by Python, or which one? Or it is
So
a
all are from the PySpark only. So these are all the built-in functions for the PySpark only. Spark.read.csv or JSON. Usually, if you guys are actually attending my first advanced class, right? So these are very, very important to whatever I am saying. So now we have to just create a job. Maybe I cannot, focus on the PySpark, right? So that is the reason I am just directly went to the job. Usually, how it looks like is that, so whenever we wanted to create a data frame, we will be creating a data frame from the hard coded data. So you will be understanding how to read the data from the multiple data sources. First thing, if I have a text file, how to read the data, and if I have a CSV file, how to read the data and create a data frame, JSON file, Parquet file, Avro file, MySQL, and BigQuery table. So this is the approach that we should learn. But in this bootcamp, I just told you how you can able to create an end-to-end job. But usually, if you have any file format, you should be able to read it. And if you have any file format, you should be able to write it. Sir, I have a data. I wanted to write it to the CSV file, write it to the text file, JSON file, Parquet file, MySQL table, BigQuery table. So if you have any data, you should be able to write it to the any of these formats. So that is the agenda that you guys should know. Okay, so similarly, you and when it comes to the transformations, also the transformations we should be actually learning in the advanced session is that we should be creating the schema for each and everything. Sir, I wanted to create a custom schema, so you will be creating your custom schema because we have followed the schema here. You guys see everything is considered as a string only, but that is not a string. All the things are not string. So that is the reason we are going to create our own schema. And I wanted to add a columns. Sir, I wanted to rename the columns. I wanted to select the specific columns, case conditions, order by and sort, dropping the duplicates, distinct function, filtering the data. And here we have, what is this one? Yeah, adding a, creating a one more data frame, sorry. So count, aggregate functions, grouping and aggregate functions, and union all, joins, left join, inner join, right join, full join, cross joins, all of the joins. And here we have left to inner, right to, and again we have, sir, if I have it, the data which is in the form of a nested fields. You guys look at it here. Sir, I have a nested fields, 1, 2, mail, and the project details are 2 records. So this is not a nested data. So when you have a nested data, how do you read the data? Okay, so ranking functions. Okay, and similarly splitting the data, concatenating the data, substring the data. So all of these transformation will come into the picture once you have learned all of these, loading, introduction, loading, transforming, and extracting all of these things. If you learn, then we will be going to the creating a PySpark job. So that is what the job that I have told you. And after that, so you should be able to create an end-to-end job. So this is how the agenda should be. But these things will be covered in the advanced session, guys. But if you guys wanted to use the data proc, so in the data proc, you can create a PySpark job. And creating the PySpark job, I have just told you how to create a PySpark job. Okay. Yeah. Any question here, guys, in our PySpark job? Sorry. Yeah, this is the one. So in our PySpark job, if you have any questions, you can ask me.
so PySpark is a separate API for Python, right?
PySpark is one of the highly used data processing framework. Okay, it's a very, very extensively used data processing framework. It is for the big data.
So it's built on any other programming language?
Python.
Oh, Python.
Python with Spark is nothing but a PySpark.
Okay.
Yeah. Any other questions, anyone?
Any other frameworks like other than SpicePark to
You have it's not Spark, it's Spark you say. It's a Spark. Okay, Spark is a data processing framework. Similarly, you have a Beam. Beam is also there, which is as a processing framework. You have such kind of a processing frameworks are there. Okay, Apache Beam.
Sir, in real time, how big the data will be available and how long it will take to transform the data into big query, sir, in real time?
So it even in the
Basically
real
from
time
min to
also,
max.
this is what is the process. Even in the real time also, this is what is the process. But now you are running it manually. So this whatever the code that you have written, right? You will be creating it as a job, nothing but some Python file, and you are going to submit it to the cluster. Okay, so it will be running in the cluster all the time, and it is scheduled. So that is what happens in the real time. But the code wise, this is how the code will be. Okay, when it comes to the code, this is how the code will be. Maybe one or two transformations or one or three transformations they are going to add it, but the code wise, this is how the code looks like, and this is how you have to write the code and test it. Once you have tested it, you have to submit this job to the Dataproc cluster, and it will be running in the Dataproc cluster from now on. Okay,
Yeah.
so here you will be having the jobs, right? So that job will be listed out here.
Okay, so do we need to write the code from scratch onwards?
No, you just have to put it into an entire thing into the one cell. Okay, whatever you have written here, right? So
Okay.
this cell, this thing, you have to put it into the one cell. That's it.
Okay, sir.
Okay, yeah, and you can submit it to this one. Any other questions, guys?
Sir, for PySpark, why we chosen Dataproc only? Is there any other also?
So in the Google Cloud platform, if you wanted to work with the Spark environment, you have only the Dataproc available. You do not have any other services. Okay. In Dataproc, if you wanted to work with Spark and Hadoop environment, we have to work with Spark, the Dataproc only. You do not have any other services. Okay. Yes, guys. Any other questions?
This is like a pipeline. It's a kind of Jenkins pipeline, right? I can say.
It's a pipeline. It's actually a pipeline. So what happens is that it reads the data from some source, and it do the transformation, and it loads the data to the some destination. You call this as a ETL pipeline. Okay, it's like a ETL pipeline. So this is how the data pipelines are created. So this is what we call it as a data pipeline creation. So whenever you wanted to create a pipeline, if you wanted to create a pipeline using the Spark, you come to the PySpark and you try to create it. Okay, so you have a source connection, you are doing a lot of transformations, and you are loading the data to the destination. So this is called as a pipeline only, an end-to-end pipeline only. Okay.
Sir, it can be possible, like I see the from CSV file, we created the ETL pipeline. Is it
Correct.
like from database from
Also we can do.
instead of taking from files, right? We take from database and we can process the create data pipeline.
Perfect. You can also do that. See here. So if you have a MySQL table that is there in the data is there in the MySQL table, you can also read the data from the MySQL and create a data frame. And then you can load the data to the BigQuery also. Anything is possible. Okay.
So this is for NoSQL also, like a MongoDB, Cassandra.
Anything. So if you have some database, you wanted to read a data and you wanted to create a data frame, that is possible. That is what we actually do in the advanced sessions. Okay. Yeah. Any other question, guys? Okay, so this is it, guys. If you have any questions, you can ask me. So this is how.
Is there any ETL pipelines improve the performance? Kind of anything will be there, sir? No.
So there are plenty of transformations, and there are plenty of optimization techniques are there. So you can go for partitioning, clustering, broadcast join, or you can go for persist, cache. There is also plenty of transformation, plenty of the optimization techniques are there that you can able to apply on top of these particular things, so that that will be actually optimized way of writing your code, and it will be running in an optimized time, so that you are going to get a little more benefit on in terms of the resources, so that the cost reduced, then time taken for the query also reduced. So all of those things will be there. Yes.
Sorry,
Okay.
I'm asking one more. Is there any standards like if we have practices ETL pipeline? This much time has to be completed to data
No,
processing.
no, there isn't anything something like that. It depends on the data that you are dealing with, and it depends on the operations that you are applying on top of it. Okay. But
So
we should be writing in a code to work with the we should be writing in a code to uh, it should be running in an optimized time. Okay.
one question, Rahul.
Yeah.
So let's say I have a PySpark job, okay, which is taking around 30 minutes currently. Okay. So in that case, I want to know in which scenario it is taking more time. Is there a way to investigate and figure out?
You have to debug it one by one. Okay, right? You will be see here. Try to think about this way only. So look at here. While you are writing this code, so you run this step,
Okay.
and after that you run this step, and after that you run this step. You tell me which step is taking a lot of time. Will you be knowing it or not? You will know it or not,
Yes, yes, yes.
right? So if this is taking a lot of time, you will know it, because you will be running this each and every cell. So once you have checked your cell, and once you have created your code, and you think that it is taking a lot of time, you optimize it there only. So once you optimize it only, then you will be creating it as a job. Okay, creating it as a job is nothing but so converting this entire code into a one single line, and just submit it to here. Just click on submit here, and you select that particular file. So if it is a PySpark job, right? So you click on PySpark here, and you select the Python file. Where is your Python file available? Okay, that's it. Okay, so you'll get to know, like whenever you are running each and every cell, you'll get to know which cell is taking a lot of time, and you click on optimize it. Okay.
So can we print a start timestamp and end timestamp for each cell so that
You can do
that
that. You can do that. Of course, you can do that. No one is stopping you doing that. Yeah. Okay. If you wanted to see the exact time difference, you'll be able to see it, or you will be able to easily find it out when you are writing a code. You will be able to easily find it out if this taking 1 or 2 seconds, and you will come to know it is still running, and it is taking 5 minutes, 10 minutes also. Then that time you will get to know. Okay, joining is one of the costly operation. We should doing a optimizing the joining condition. So the best way of writing the code, you need to think about it. Okay.
Sir, for ETL pipelines, always will be the processing steps are same, always remain be same, or in the real time project each and every time
It depends on
there.
the requirement. Okay, it always depends on the requirement. So what we wanted to do, and what is your data sources? Based on the data sources, based on the requirement, based on the use case, we all the things will changes. Okay. So the approach should be the same thing. The approach is that source we have to read the data from. Transformations we have to do it, and write the data to the destination. The approach is same. But the requirements, as per the requirement, the transformation that we are applying could be changes. So the loading the data, writing the data is different. So all of those things we need to ensure that. But the writing the code is simple. Similarly like this one.
Why I asked, right, in generally web applications, right, the pipelines will be always will be standard. When it comes to data processing, you
Data
are saying,
processing different. Data
yeah.
processing always changes. Okay. Web application pipelines, CI/CD pipelines, those are one-time writing can be used for 100 times for 100 projects. But data processing pipeline, you are writing it for this is only for this particular requirement. Okay. If you have a one more requirement, that entire data processing pipeline is different again. Okay. Some of the code can be reused, but most of the things can has to be written from the scratch.
Okay. Is there any steps we can reuse these steps?
No.
Can we write one common file
No.
instead of writing the
It's not
all
possible.
steps? It's not
Writing
possible.
a common file is not actually possible. Okay. But as per the use cases, as per the requirement, sir, I have a requirement and this requirement is same. In that case, you can write your own template. Okay, you can write your own template, but usually that is not actually happens. Every time it changes. The requirement every time it changes. Okay, the template, you can use this template, right? So you, for example, sir, I have written here. So tomorrow it is not student CSV file, it is some other file. It is not this file, it is some other file. You come here and change it. Everything changes, right? Automatically.
Yeah,
So it
the
totally
first
depends on it.
yeah, the first step it will be changing always, but the filtering and transforming these steps are common, right? That's what
No,
just is
no,
there.
no, 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 no. See here, that's what you have to understand. See here, the joining conditions changes, the joining type changes, dropping the column number of changes. For example, I may have to drop few more other columns also. And here I may have to add other column instead of country column. I may have to add other columns also, and we may have to group the data based on some other conditions. And maybe it is not grade column, some other column, and we are filtering the data on some condition. This condition may change tomorrow, so nothing can be reused. Only the syntax that when I said df dot filter, that is same, but the condition changes here. So everything is changes. We cannot reuse it actually. Okay.
But here, whatever we observe right here today, uh, transformation is more steps, extraction is one step, and loading will be one step, right, sir?
Always that is what happens. Always. So extracting the data from multiple data sources. I have here 2 data sources. Tomorrow you may have some 10 data sources. The loading step is same and the writing step is same, but the transformation takes a lot of time. Okay. Any other questions, anyone?
Can you please help me? These are all like the files in Drive, sir. We can go through once.
Sure. This I
Or
will try to upload it, guys.
In general, in today's session, what are the main interview questions may I will ask, sir?
So there will
Just
be a plenty of interview questions, guys. Usually they will ask like, how do you read the data from a CSV file? Okay, how do you read the data from a CSV file? So Spark dot read that. If they are also ask you, it's not only for this particular thing. If they'll ask you, so can you? We have a JSON file, and in the Spark we have to create it as a data frame and do the transformations. How do you read the data properly? And for applying for adding a column, which transformation you will do it? And if I wanted to group the data, how do you do that? So if you wanted to aggregate the data, what is the difference between the join? What is the difference between the left join and anti-join? And what is the different? What is a join type called broadcast join? So there are plenty of interview questions that they are asking in the upcoming sessions. Okay.
so mostly they may ask basic only, sir. So how to?
No. Actually, because when you are going as a PySpark developer and you are working on a PySpark, if you say, they will go up to the optimization levels also. That is a
Okay.
so yeah, optimization. They mainly focus on the optimization. So because if they ask for something on the optimizations, and if you are telling the answer, that means you know a good experience on the PySpark. Okay, PySpark is all more about the optimization. So writing code, every can do it, but optimized way of writing a code is important in the PySpark.
Okay, sir. Thank you.
Yeah.
sorry, last question, sir. We transformed from CSV file to BigQuery we load, right? BigQuery, is there in like a primary key, foreign key like that? It will take no, right?
In the
It's
BigQuery
not.
also we have a primary key, foreign key. Yes, they have recently introduced. Yes, it is there.
But as of now, we've seen this for the tables. We have like a procedures and functions also.
Of course,
Okay.
you'll be having a stored procedures. You'll be having a functions, views, everything. Okay, so all of those things will come into the picture. Yes. Okay. Okay, guys. Yeah. Thank you all, and
Thank you.
we will see tomorrow, guys. Okay. Yeah. Thank you all. Have a great day.
Thank you.